Let's jump right in. Welcome to this explainer. Today, we're diving into a truly mind-bending hypothesis about what actually holds our universe together at the absolute smallest scales. I mean, we're talking about the literal fundamental bedrock of reality itself. Okay, so let's start with a pretty simple observation. If you look at the grand scheme of things, our universe is mostly just empty and dead, right? Yet scattered throughout, we have these rare, beautiful oases of complexity. And they're built almost like a ladder. You know, energy, particles, atoms, stars, planets, and eventually us. But to really understand how this whole shebang works, we need to figure out what forms the absolute bottom rung of that ladder. Like what actually lies at the absolute bottom. Section 1. The pattern of locks. To wrap our heads around this deep mystery, we actually need to start with the forces we already know, kind of zooming down from our everyday reality. As we zoom in on this ladder of complexity, we see that each rung is held together by a specific fundamental force, basically acting as a lock. So first, you have chemical bonds holding molecules together using the electromagnetic force. Then, down a level, nuclear bonds lock protons and neutrons together in the nucleus using the residual strong force. And then we hit quark confinement, where the strong force literally locks quarks tightly inside those protons and neutrons. Now, this perfectly illustrates the absolute massive contrast in scale when we talk about breaking these locks. Think about it. Breaking a chemical molecule, that gives you the energy of a lit match, or maybe a stick of TNT. Breaking a nucleus, well, that unleashes the devastating energy of an atomic bomb. But breaking a quark lock, if you could somehow manage to do it, that would unleash matter-antimatter levels of pure energy. It's just wild. And that brings us to the crucial point, this underlying mathematical pattern built around the number 1000. Notice the trend here. Each deeper lock we just looked at is roughly 1,000 times stronger, operates at 1,000 times shorter range, and releases 1,000 times more energy when broken. It's a remarkably consistent progression. Section 2, meet the hyperforce. So if this undeniable pattern of 1,000 holds true, well, we kind of have to follow the logic down one more step. We've currently reached the absolute edge of known physics at the quark, but following our pattern naturally leads us to a massive question. What actually lies beneath the quark? What could that next lock possibly be? Well, this introduces us to a radical, yet honestly highly logical hypothesis known as the hyperforce. This proposed fundamental interaction would be even deeper than the strong force. It would be the ultimate hidden lock holding together even tinier subquark components, these theoretical particles physicists call preons, at mind-bogglingly small distances. We're talking smaller than 10 to the negative 19 meters. Let's flesh this out a bit. The hyperforce would be immensely stronger than the strong force, possibly reaching all the way down to the Planck scale. It would be incredibly short-ranged, 10 to the negative 22 meters, or even less, and it would be mediated by its own unique boson, which has been theorized as a hypergluon. Basically, the hyperforce would be the absolute final lock before we just hit the fundamental fabric of space-time itself. Section 3. The black hole barrier. Okay, so here is where we arrive at the most profound, completely mind-bending implication of this entire hypothesis. The lock is self-guarding. What this means is that this ultimate lock can literally never ever be broken. And it's not just because our particle colliders aren't powerful enough yet. No, the reason is dictated by the fundamental laws of physics. Here's exactly why. To split a quark and free one of those preons, you'd have to concentrate an unimaginable amount of energy into a ridiculously tiny subquark volume. But physics has a hard limit here. If you pack that much energy into that small of a space, you create a black hole. And, crucially, the event horizon of that black hole would grow with the energy, ultimately becoming larger than the quark itself. So any attempt to pack in enough energy to liberate a preon just creates a black hole that permanently hides the interior. The hyperforce is essentially forever hidden behind an event horizon. And this physical barrier forces us to consider a stunning, almost sci-fi possibility about the very nature of these tiny particles. What if the preons themselves are microscopic black holes? Let's break down this micro-black hole hypothesis. At the Planck scale, the distinction between an elementary particle and a black hole literally blurs together. They kind of become the same thing. And if our universe happens to have extra dimensions, this fundamental scale could actually be lowered to energy levels we can almost wrap our heads around. If this is true, a quark isn't just a little point-like dot. Instead, it's a tiny molecule made of 2 or 3 stable microblack holes held together by quantum gravity, which means reality might literally be black holes all the way down. Section 4. Predictions and Problems. Now, as much as I love an awe-inspiring concept, we have to balance it with strict scientific rigor. This theory does offer some tantalizing, potentially testable predictions, things like extremely rare proton decay, new resonances at ultra-high energies, or even fossil gravitational waves from the early universe that future observatories like LISA might detect. But we have to impartially weigh those against the serious friction the theory faces. It has massive unexplainable problems, an ultimately untestable barrier, and the stark reality is that right now we have absolutely zero experimental evidence for it. The absolute most glaring issue we have to report on is the mass problem. It's a big one. See, if quarks are actually made of Planck-scale black holes, their mass should be around 10 to the 19th giga-electron volts. Yet the actual observed mass of light quarks is just a few mega-electron volts. They are unbelievably light compared to the immense scale they supposedly come from. And this requires a level of unnatural fine-tuning in the physics that scientists really struggle to explain. Section 5. The Guardian of Complexity. But despite those massive theoretical problems, let's zoom all the way back out for a second to see why this concept is still so deeply appealing to people studying the fabric of the cosmos. As the saying goes, black holes are nature's way of hiding its deepest secrets. You see, that black hole barrier we discussed earlier, it isn't just some frustrating obstacle meant to annoy scientists running experiments. It's actually a vital, beautiful feature. It ensures that the bedrock of reality is permanently stable. Think about it. The Hyperforce provides an unbreakable lock at the absolute deepest level of reality. Because this lock is self-guarding, meaning you literally can't break it without creating a black hole, quarks don't fall apart. And because quarks don't fall apart, protons can exist, which means atoms can exist, chemistry can exist, and ultimately, we can exist. It locks away the universe's greatest energy density, allowing for the slow, gentle flow of energy that builds everything we know and love. If the hyperforce actually just is quantum gravity acting at these microscopic scales, we get this incredible reverse zoom-out of existence. Starting way down at step 1, Planck-scale black holes, which build up to step 2, quarks. Those build protons and atoms, moving all the way up to molecules, which eventually give rise to life, and finally reach step 6, intelligence. An intelligence which, who knows, might one day learn to engineer entirely new universes by manipulating these very same scales. So, I want to leave you with this final thought to ponder. Are the deepest locks in the universe meant to be forever beyond our reach? Perhaps the ultimate reality, being locked away behind a black hole horizon, is exactly as it should be, providing the perfect, unbreakable foundation for our beautiful oasis of complexity to thrive. Thanks for exploring this with me today, and keep questioning the universe.